You know, it's one of those first big questions we all ask as kids, and maybe one you haven't really thought about in a while. So today, let's dig into a simple question that has a surprisingly cool answer. Why is the sky blue?
I mean, have you ever really wondered why blue? Why not green or purple or orange? Today, we're going to unpack the science behind that beautiful blue canopy above us. And it all starts with something as simple as a single sunbeam.
All right, so to crack this mystery, we've got to start with what sunlight actually is. Because, well, it's not as simple as it looks. That's right, that plain white light you see streaming from the sun isn't just white. It's literally a mashup of every color in the rainbow. I mean, if you've ever seen a prism do its thing, you've seen this happen. It splits that white light right back into all its colorful parts. So this whole collection of colors, that's what scientists call the visible light spectrum. It's basically the slice of light that our eyes are built to see. And the key to really getting this is to think about light in a totally different way. Yeah, forget thinking of light as just a straight, steady beam. Instead, picture it as energy moving through space in waves, kind of like ripples spreading out on a pond. And trust me, the shape of these waves, it's everything. So the color that our brain actually sees depends completely on the light's wavelength. Look here, red light travels in these long, lazy, stretched out waves. But blue light, it travels in much shorter, choppier, more energetic waves. Now, hang on to that difference. It's the first major clue in our mystery. Okay, so we've got our rainbow of light waves shooting from the sun, but what happens when they actually get here? Well, that brings us to the second key ingredient in this recipe, the air itself.
Our atmosphere. It's this incredible, life-saving blanket of gases wrapped all around us. We can't see it, but it gives us oxygen, it keeps us warm, and as we're about to find out, it's the very thing that paints our sky blue.
So think about it. Every single ray of sunlight, with all its different colored waves, has to fight its way through this huge obstacle course of gas molecules to get down to us. And that journey, oh yeah, it changes everything. All right, let's recap. We have our two main players, the multicolored light waves from the sun and the invisible filter of our atmosphere. Now, let's see what happens when they finally meet. So, sunlight dives into the atmosphere and bam! It starts colliding with tons of tiny gas molecules. But here's the kicker, the really important part. Remember those short, choppy blue light waves? Well, they're the perfect size to get bounced around and scattered in every single direction by these gas molecules, kind of like a pinball. Meanwhile, those longer red and yellow waves, they mostly just cruise right on through. And that's the secret. The blue sky isn't actually a thing, it's an effect. When you look up, what you're really seeing is all those scattered blue light waves coming at you from every direction at once. It's a sky-wide light show, happening all the time. Okay, that totally makes sense for the middle of the day. But wait a second. If the sky is blue because blue light scatters so well, then what in the world is going on with those fiery red and orange sunsets? Well, the answer is all about geometry, really. At midday, the sun is pretty much right on top of us, so its light takes a pretty short, direct path through the atmosphere to reach our eyes. But at sunset, the sun is way down on the horizon, so its light has to travel through way more atmosphere to get to you. And on that much longer trip, almost all of the blue light gets scattered away from your line of sight before it can even get to you. So what's left? Well, it's the longer waves that didn't get scattered. The reds, the oranges, and the yellows. They get to make a straight shot to your eyes, giving us that spectacular grand finale.
But you know, this whole thing isn't just a pretty light show. It's actually super useful. The color of the sky can tell us a whole lot about what's actually in the air we're breathing.
So, you've probably seen this, right? When it's not just the sunset on the horizon, but the whole sky kind of has this hazy reddish glow, even during the day. What's that all about? It means something else besides just gas molecules is getting in on the light scattering game.
Yep, these larger particles, which scientists call aerosols, are also fantastic at scattering away that blue light. So when there's a lot of dust from a storm or smoke from wildfires or even heavy pollution hanging in the air, they filter out the blue light even more, which leads to those really deep, sometimes almost eerie red skies.
And this is where the science becomes a really important tool for our safety. NASA has these incredible satellites that create these amazing, detailed 3D models of what's happening in our air, constantly keeping an eye on aerosol levels. And all that data helps us forecast air quality and gives us a heads up when the air might not be safe to breathe. You know, it really puts it all into perspective, doesn't it? A blue sky is more than just pretty.
It's a good sign, it's a visual cue that the air is clean and that sunlight has a clear shot down to us. It's the color of a healthy atmosphere doing its job.
So, I'll leave you with this one last thought. The next time you see one of those absolutely stunning, deep red sunsets, just take a second and wonder, is it just the sun's long journey home for the day? Or is there something else in the air? Dust, smoke, maybe some haze? Painting that beautiful and very telling picture. What's the air trying to tell you today?